Okay, another day and another starter. We're going to do some simplifying of algebraic fractions again, but this time it's going to include this skill, which is why I want you to practice it a little bit. We've got some expressions here, and I want you to factorise these. That means to put into brackets, please. So pause the video, write the question and the answer, and unpause when you have done all 9. Thank you. You've unpaused, let's go. First one, I could divide both of these by 2, so that's a factor of them. I can take it outside of a bracket and then try and make this expression starting with 2. Well, 2 lots of 2x would make 4x, and 2 lots of 9 would make 18. You've got to think, if you expanded this, would you get the original expression? In this case, yes I would. 2 lots of 2x is 4x, 2 lots of 9 is 18. Both of these would divide by 5, so it's a factor of them, so take it outside the bracket. Now 5 times 2x would make 10x, and 5 lots of negative 3 would make negative 15. Again, just do a little mental check, expand it out in your head. Would it, not in your head, but like in your head, do the expand, you know what I mean. Would it equal the original expression? Right, both of these can be divided by 5, but also there's an x squared and an x. They both share an x, so that could go outside of the bracket. Now, if you're not sure about your factorising, definitely go to Dr. Frost or My Maths, whatever website you're on, and go and do some practicing and remind yourself, because it's an essential skill for this. Now, I've got 5x and I need to make negative 15x. So I'm going to times it by minus 3 to make negative 15. But also there's an x there. Oh, and there is an x. That's great. Done. Just expand it in your head. Would it be that original expression? This time, divide both by 4. And they've both got a y, so that can go outside the bracket. And we need 4x on the inside. 4 times 4 is 16. X times y is xy. And then negative 3, because 4 times negative 3 is 12. I've got a y, and we need a y. So, job done. 5x plus 5. Good. Well, that seems easier, doesn't it? 5 can go on the outside of a bracket. We need the x to make 5x. But then I've already got a 5, but I still need something there. So I put in a 1, because 5 times 1 would make 5. What I've actually done, really, is, divide that by 5. There's 1 5 and 5 to make 1x, and there's 1 5 and 5 there. And that 5 has gone outside the bracket. 5 lots of 1x plus 1. Yeah? Don't forget that. Otherwise, if you didn't put the 1, that 5 would just sort of disappear if you tried to expand it again. This time, 3x can go on the outside of the bracket, and we'd need 3x plus 2, because 2 lots of 3x makes 6x. Quadratic equation. Okay, I'll show you on the first one. Well, expression, sorry, not equation. Factor pairs for that n number. 1 times 6 is 6. 2 times 3 is 6. Which pair adds to make the coefficient of x? Which is a posh name for the number touching x. 2 and 3 added together would make that. So they multiply together to make 6, but add together to make 5. So we would have in one bracket x plus 2, because it's positive 2, and x plus 3, because it's positive 3. If you did the same things for these ones, you would also end up with x plus 1 and x plus 2. So I was just doing it in my head then. 1 times 2 would make the 2, but the added together 1 and 2 makes 3. Again, if this is something you're not sure about, factorising quadratics, this is not the time for me to sort of practice it for you. I'm showing you another skill, so you need to go off and do some other practice of factorising quadratics. Right, negative 10, let's see. I'll tell you what, let's do this one properly. So 1 times 10 is 10, and 2 times 5 is 10. But this is negative 10, so it might be minus 1 times 10, or minus 2 times 5. But think of this, it could also be 1 times negative 10, or 2 times negative 5. You sort of have to do the list twice, with each part of its pair being negative. Now in this case, to make positive 3, I'm adding together these two, negative 2 and positive 5. They multiply to make minus 10. They add together to make positive 3. So it's x, take away 2, and x plus 5. Because the 2 is negative, the 5 is positive. Okay? Cool, that's a useful skill for what we're going to do. Right. Firstly, let's do it a little bit without factorising to show you what's going on. Now, if I had up here, I'm just going to write a very simple algebraic expression. What if we had 4a over a? Well, the a would cancel out. I divide that by a and that by a, which would leave, 4 times 1, which is just 4, divided by 1. It's just 4. The a's cancel out, don't they? Because it's on top and underneath, it cancels out. And the same thing happens here. I've got that up there, cancels out that little bracket down there because they are equal. We've got 4 times that bracket on top, that bracket underneath, they cancel out, just like it would if you had 4a over a, or 4x over x. The bracket is a unit, in its own right. And so they cancel out. As long as the contents of the bracket are equal, they will cancel out. This one, look, again, I've got this bracket times by this bracket on top, x plus 2 times x minus 1, and underneath I've got x plus 2. Well, think of it as a little unit. If you put brackets in, it's not going to change the expression. But what it does mean is you can see that that bracket up there will cancel out the bracket underneath, leaving x minus 1. Okay, you can put it in brackets or not, it doesn't matter because there's nothing else there. All right, does this blow your mind, or is this nice and easy? Okay, we've got 2 brackets multiplied on top, 2 underneath, but there's a matching pair. There's y plus 1 on top and y plus 1 underneath. Because they're multiplied, they will cancel out, and we'll be left with the y minus 1 over y plus 5. And again, if you wrote them in brackets, it wouldn't matter. You just sort of don't need to when there's nothing else around. Right? I sense you're not happy with that. But, let's do a little explanation of that one. Let's say I had AB on top, and I had, what's the B? Let's put, BC underneath. Well, the B's would cancel each other out to leave A over C. And that's what we've done here. One bracket over the other. All right? Last one then. What about x plus 5 all squared over x plus 5? Well, think of that as a bracket. Maybe it helps if I actually write this out in full. If something is squared, then it's times by itself. So it's that bracket times by itself. Okay, but that is also identical to this bracket underneath. So one of the ones on top will cancel out one of the ones underneath, leaving just x plus 5 on its own. Oh, that is dreadful writing there. Guys, that's so bad, I'm going to redo that. So, as I was saying, it leaves x plus 5 on its own. All right? Have a little go at those. That's gone straight through my writing. Never mind. See if you can spot some stuff that can be cancelled out. There might also be other things, other numbers. Don't forget what we did before. But yeah, pause the video. Just have a go at those. Make sure you write down the answer as well as the question. And unpause when you're done. Like now. Well, y minus 2 is on top and underneath. They cancel each other out to leave 5. This one. Okay, let's do the numbers first, actually, because the numbers will divide as well. So 18 and 6 both divide by 6. 3 6s in 18, and there's 1 6 and 6. But also, this bracket will cancel out this bracket. So I've now got 3 on its own on top. And 1 times by this bracket. Well, I don't need 1 times by the bracket. I just put one lot of the bracket. Very much like 1x, you just write x. Same thing. X plus 4 over x plus 4, x plus 5. Okay, now this one underneath, this x plus 4, isn't going to cancel out both of the ones on top. It's only going to cancel out one of them. Right, because I've got, again, if you think about, if I've got a squared, so that's a times a over ab, the a underneath is only going to cancel out one of those ones on top to leave a over b, isn't it? And the same thing here. We've got x plus 4 over x plus 5. And again, it doesn't matter if you left it in a bracket, just don't need to. This one, a bit more straightforward. X plus 2 and the x plus 2 cancel out. So it's x minus 1. This one, we've got some numbers, so they divide. So let's do that, simplify. Both of those divide by 4 to leave 1 and 2. And we've got a y plus 1 underneath in a bracket, which cancels out the y plus 1 on top. So we've got one lot of y minus 1. So that's just y minus 1. 1 times that. And then 2, well, just 2, isn't it, underneath. Job done. Okay? Now, of course, wouldn't it be marvellous if it was that easy in the exam? Unfortunately, they tend not to make it that simple. Often we have to factorise first, all right? But it's not a hard job, and they usually give you a bit of a hint. Like there's an x plus 1 here. I suspect that will come up in a minute when I factorise the top of this first. So factorise first. 4x plus 4. Well, that would factorise to 4, and then x plus 1. Oh, and what do you know? That matches the x plus 1 underneath. So it cancels out to leave 4. Okay, well, this one. Then factorise them first. So 5x plus 10. Let's divide those by 5. So 5x plus 2 over, well, these would divide by 3, wouldn't they? So 3 x plus 2. Right, okay, so we've got x plus 2 on top, x plus 2 underneath. So it equals 5/3. Or you could write it as 1 2/3. Okay, get the idea? So factorise it. Find these little, factor brackets. If there's one on top and underneath, they can cancel each other out. Right, x minus 2. Now, looking at this, bit of a hint, isn't it? X minus 2. I suspect we're looking for that on top. Let's see, what have we got? 3x squared minus 6x. Well, they both divide by 3. And there's an x in each bit, so we'll take that outside of a bracket. 3x squared is what I need to make. And I've got 3x, so there's just an x left over. Take away, well, 2, I've got the 3. 2 times the 3 would make 6. And, or I've already got an x. That would work, wouldn't it? Minus 2 times 3x would make minus 6x. And of course, underneath, we've got x minus 2. Look, they cancel out to leave 3x. Okay. 5x minus 20. Well, let's factorise that first to get, let's divide this by 5. So 5x minus 4. Oh, okay, I can see where that's going, because then we've got x plus 5 and x minus 4 underneath, and the x minus 4s cancel out, leaving 5 over x plus 5. Okay. Yeah, you're fine at this. Just do your factorising and then cancel out what you can. Okay, so pause the video, have a go at that, unpause when you're done. Let's see, right, if we factorise this, we get 3m minus 2. Factorise the bottom one, and you get 2m minus 2. Okay, they cancel out to leave 3 over 2, or 1.5. Yeah, cancel out. This one, an m can come outside of the bracket, which leaves m plus 3 inside the bracket. 3m plus 9. Right, okay, well, they both divide by 3, so 3 can come outside to leave m plus 3. Oh, cool, the m plus 3s cancel out to leave m over 3. Just some basic factorising here. Right, minus 2x minus 4. Okay, so minus 2 can come outside the bracket, leaving x. Now, what do I times minus 2 by to make minus 4? Well, that would be positive 2. Right? Now, if you've got that wrong, that's just a little bit of negatives work you need to think about. Concentrate on it. If you multiplied this out, would you get the original expression? That's the question you've got to ask. Then minus 2 again, and that would be x. Oh, no, hang on. It's not x, is it? That is going to be 3x, because it's minus 2 times the 3. And then, how do I make minus 4 starting with minus 2? I times it by positive 2. So this time, it's not the brackets that cancel out, but the numbers, the minus 2 and the minus 2. So x plus 2 over 3x plus 2. Okay, so when you're doing these factorising, it's not always the little brackets that cancel. Sometimes it's other bits and pieces. Right, x and x minus 3 would be the top of that fraction. Underneath, x squared plus 2x, x can be taken outside, which would leave x plus 2. Again, we've got an x and an x that cancel out, which leaves the bits inside the brackets left over. X minus 3 over x plus 2. Last one. Okay, the top doesn't seem to factorise at all. So let's have a look at the bottom, see what that does. Well, I could divide these by 3x. 3x could come out of both of these elements. So let's put 3x outside a bracket. I need to make 6x squared, so I times it by 2 and by another x. And I need to make minus 3x, starting with 3x. Well, how do I make minus 3 from that? I times it by minus 1. And look what's on top of our bracket. Don't mean that. I mean on top of our fraction, 2x minus 1 and 2x minus 1. Okay, now what are we left with? Underneath it's easy, 3x. Now, what we've actually done here, I know I keep saying it cancels out, but what I've actually done is divide this bracket by 2x minus 1. That just leaves 1. And then divide the top bracket, 2x minus 1. I divide that by 2x minus 1 as well, which also leaves 1, because anything divided by itself is 1. So what I'm left with on top of my fraction is 1, and underneath I've got 3x times 1, which is just 3x. Right, so don't forget that you can't leave the top of the fraction blank. You know, there needs to be that kind of almost like a placeholder essentially in there. Okay, I hope you did all right on those. If not, maybe have a little listen back. It does take a bit of practice, but you get the idea in the end. What about this one then? I've now got a quadratic equation on top of there. I hope you're quite good at quadratic equations now, and you can maybe even factorise them generally just by looking. Now this one, a pair of numbers that multiplies together to make 3. Well, there's only one pair really, isn't there? 1 times 3, because it adds together to make 4. So it's x plus 1, x plus 3. And there's a bit of a hint again, isn't there? The x plus 1 underneath kind of shows you that if we're going to simplify this at all, one of the brackets on top must be x plus 1. And that will leave x plus 3. Essentially it's x plus 3 over 1, but we don't need the divide by 1, do we? So it's just x plus 3. Yeah, okay, now we've got 2 pairs. So let's do a bit of factorising here. All I'm doing is just factorising the quadratic equation, finding the pair of numbers that multiplies together to make 6, but adds together to make 7. And that would be 1 and 6. 1 times 6 is 6. 1 plus 6 is 7. So we've got x plus 1, x plus 6. Now underneath, what have we got here? Again, this time I need to make minus 6. Now again, it's nothing wrong with it. Okay, the top one was easier to do. If you're not sure about the bottom one, you know, why not just write out your factor pairs like you've done before? You know, see which factor pair you need to make positive 5. That's going to be 6 take away 1. So those are my 2 numbers, x minus 1 and x plus 6. And there we go, there's the brackets that are going to cancel out. There's an x plus 6 on top and underneath. So our fraction simplifies to x plus 1 over x minus 1. All right? Cool, okay, 4 for you to have a go at. Just going to put it out there. Difference of 2 squares. Okay, pause the video. Just say it again. Difference of 2 squares. Pause the video, factorise those and simplify them, and unpause when you're done. You've unpaused because you're amazing. All right, and I feel like a change of colour for my pen. I'm going to go for the absolutely hideous magenta. And I think I might sneeze in a second, which is going to be entertaining. Right, this first one, we've actually already done this, haven't we? Oh, sorry, I didn't notice. It's too late to change it now. But if you didn't notice, well, then I am laughing at you. Because that's the same question that we did up here. I've already done the explanation for it. It's x plus 3. All right. That was a bit silly on my part, wasn't it? Okay, let's try this one. Right, factorise the top. We factorise one similar to this, but not quite the same. This is actually x plus 2 and x plus 3. It doesn't actually matter which way round you do it, just as long as you've got both. This one would factorise to x. Let's see, we've got negative. I see. Okay, so we got x minus 4 and x plus 2. Again, doesn't matter which way round they go, as long as the 4 is negative and the 2 is positive. What cancels out? Well, that would be the x plus 2's, wouldn't it? To get x plus 3 over x minus 4. Now, this colour actually makes me want to vomit, so I'm going to change to... what should we go for this time? Let's just go back to blue. Okay, this one factorises. It is kind of a quadratic equation, but actually the only thing you take outside the bracket is an x. So it's x plus 5 on the inside. And then underneath, again, x, and this time it's x plus 4. And this time it's the x's that cancel out to leave x plus 5 over x plus 4. Remember, it's not always the brackets that cancel out. Now, did you take my hint on this one? I wonder. Right, the top of this is x plus 1 and x plus 1. 1 times 1 is 1. 1 plus 1 is 2. Now, the bottom is difference of two squares. I did say it twice. That's one square number. Take away another square number. So it's x plus 1, x minus 1. All right? Didn't do that. You know, watch out for those difference of two squares. They pop up in all sorts of funny little places. Don't forget about them. They will come in your exam at some point. So x plus 1 over x minus 1. Oh, which is the same answer as this one up here. That's exciting, isn't it? I use the exciting in a very strange way there. 4 more to have a go at. Difference of two squares. And don't forget that if you could divide every element by something, you could simplify it maybe. I'm just putting it out there, all right? Whatever. Pause the video. Do all 4 questions. Unpause when you're done. Okay, we've unpaused. Sorry if you can hear the chuntering in the background. That's just someone rabbiting on about Fortnite or something like that. Okay, so on top of here, let's factorise. We've got to make minus negative 3, so that's going to be x plus 1 and x minus 3. Again, doesn't matter what order it goes in, as long as they're both there. And underneath that, actually, we can just... This is a linear factorising, it's not quadratic. So 2, and then x minus 3. And then we've got the x minus 3's that cancel out. So x plus 1 over 2. This top right one... I feel like we've done this one before. Is this the one we did before? I don't know. So I've got x plus 6 and x plus 1. Again, doesn't matter on the order. And then, yeah, we did this before, didn't we? Oh, silly me. Or silly you if you didn't notice. We've got... Oh, yeah, what am I trying to say here? Yeah, it's minus 1, isn't it? And x plus 6. Yeah. Okay, so we've got the x plus 6's that cancel out. Yeah, this is exactly the same question we did before. But it's good practice. Now this one, tricky, isn't it? If you could factorise this completely, probably with the 2's, but actually you can divide every element in this fraction by 2. Which is going to make things a bit easier. Now, my equation on top is now x squared minus x minus 6, which factorises to be x minus 3 and x plus 2. And underneath, difference of two squares, it's x squared, take away 9, which is x plus 3, it's x minus 3. Again, doesn't matter on the order as long as they're both there. And the minuses cancel out to leave x plus 2 over x plus 3. X plus 2 over x plus 3. Not very neat, but it is there. Difference of two squares again. Probably a bit easier this one really by now. The bottom is difference of two squares, so it's x minus 2, x plus 2. Doesn't matter on the order as long as they're both there. And the minus 2's, or x minus 2's, cancel out. Remember, you need that placeholder on top, because what you've really done is divide top and bottom by x minus 2, which leaves 1 times x plus 2, and 1 just on its own on top. Okay. Right. This is important, okay? Last little bit here before you go do some Dr. Frost. Often, they give you a clue. Right? They give you a clue. So if you're not really sure, or you're finding the factorising tricky, it's kind of a bit of a clue there. Right. I mean, look at this one. I've got 2x minus 6. Now, the bottom of this factorises to be 2x minus 3. So, if we're going to simplify this at all with the top one, it's quite likely that the top is going to have an x minus 3 in it. Okay? That's a bit of a clue to the factorising, because look, I need to make 2x squared, which means the other bracket must have 2x in it. It's a quadratic equation. Now, let's think of what we've got here. If I multiplied this out, we're going to kind of do it by inspection, right? It's like a bit of educated guesswork. 2x times by x will make 2x squared. 2x times negative 3 will make negative 6x. Okay, now I don't want negative 6x, I want negative 5. So I'm going to need one more x in there. Alright, so this actually, if you factorise this, you get 2x plus 1, x minus 3. And the reason I found that easy is because I kind of first of all use this clue that the bottom factorised to leave x minus 3, which means the top's got to have an x minus 3, because like this is an exam question, right? We're in an exam. This is not real life where it might not simplify. The whole point of the question is to simplify it. Right, so it's a bit of a clue. It just gives you a hint as to what the factorising might be. So we've got, 2x plus 1 left on top and 2 left underneath. Okay, let's try another one. So on here we've got the 4x, oh sorry, not 4x, x plus 4, sorry, I'm trying to say down here. And so that's a huge hint that there's bound to be an x plus 4 sort of element underneath, all right? You know, if we're going to factorise this quadratic equation here, or expression, part of it's going to have to be x plus 4, or it's not going to simplify. So let's see if that's a good hint as to how to factorise this. Now I need 3x squared. Just like up here, I got 2x squared from doing 2x times x. Here, the only way I'm going to make 3x squared is if there's 3x in the other bracket. 3x times x makes 3x squared. Right? But I also need to make 8. Two numbers times together make 8. Well, that's going to be 2, isn't it? And let's just check out that this works. So 3x times by x makes 3x squared. 2 times 4 makes the 8. Now, can I get 14x? 3x times by the 4 is 12x. And then the 2 times by the x would make the extra 2 to make 14. All right? So I have got this x plus 4 on top and underneath. They cancel out to leave 1 over 3x plus 2. Okay, well, now, you don't have to use this method at all, right? I just like to think that it's a good kind of clue as to what's happening in the question. And so it means that sometimes it makes factorising a bit easier. Now, if you're not sure, you could always, you know, factorise using the method where you multiply the two outside numbers together. You know, if you've got a method for factorising when it's not just x squared, but say 2x squared or 3x squared, then use it. You know, it doesn't matter. It's just, say, sometimes this gives you a bit of a clue, a bit of a hint as to where it might actually be going. All right? Okay, so off to Dr. Frost with you to simplify some algebraic fractions with factorising. Really important that you try and nail this. So if you get one wrong, don't just ignore it. Go back, have a look at it, ask me for help, ask your teacher for help, whatever. Ask someone for help. You know, make sure that we're actually trying to get every single one of these right. Spend your time in it. Don't skimp on that. Okay? Right. Well done. See you next time. Bye-bye.